All right, so what we're looking at here is really using the unit circle. This is an exercise that you could just put all of the stuff in your calculator, solve all the problems like that. But we want to try and use the unit circle to become more familiar with it. So here we're going to fill in this table and we're going to use our unit circle to do it. We're given some angles and we're asked what's the sine value when the angle is 5 pi on 4. So let's flick to the back for our unit circle there. Here it is. We need to run around the unit circle until we find the angle 5 pi on 4. All right, 5 pi on 4, it's over here. And we remember sine is the y value. Okay, so the y value at 5 pi on 4 is minus root 2 on 2. Okay, root 2 on 2. Now, just to reiterate, root 2 on 2 is the same as 1 on root 2. You'll see it expressed in different ways. One way you can check if you're unsure is just convert it to a decimal in your calculator. So that's the y value, all right? Next we're asked, okay, what about cos of that angle? What about the x value? And you see the x value is the same at that point. And on our back unit circle here, we even have the tan values listed, right? Tan is sine divided by cos. So if we have the same thing dividing itself, it evaluates to 1. And we can see the tan value on the back of our unit circle there as well. Okay, minus 60 degrees. So this is a good place for me to emphasize those negative angles. If we have minus 60 degrees, it means we're going back this way 60 degrees. Okay, it means we're going from 360 back 60 degrees. Our new angle is 300 degrees. That's our position on the unit circle with a positive angle. So you look at where the angle is 300 degrees and we're saying what's the x value, what's the y value, what's the tan value. So sine is the y value. This is minus root 3 on top of 2. Cos is the x value. It's positive half. Okay, we've got the tan value written there, but I want to evaluate this one manually so you can practice the fraction operations, right? Tan is sine divided by cos. So that means our tan of, what's our angle? Minus 60 degrees is equal to the sine value minus root 3 on 2 divided by our cos value, half. Okay, so I want to teach you how can we divide these fractions by one another. I've got two processes written up here. This is the one you probably learned in sort of year 7, 8 maths, okay, flipping the denominator. I think this is a better way to think of it. If we have one fraction divided by another fraction, it's equal to the top and the bottom multiplied together and the two middle ones multiplied together. So you can see A, B, C, D, what it's going to become. Okay, now we've got a negative there as well. Let's deal with that first. If I have a negative, this whole thing's negative, this whole thing's positive, and negative divided by positive, the result is going to be negative. Okay, so we've dealt with the negative, it's got to hang out the front. All we've got to do now is evaluate these numbers, right? And so I'm saying A times D. A times D, so that means we've got 2 times root 3 at the top, and at the bottom, B times C, 2 times 1 at the bottom. All right, we have 2 at the top and the bottom as a factor, so it can cancel. It's a product at the top and the bottom, and so we're left with minus root 3 on top of 1, which is minus root 3. Okay, so the point of that, like we can get the tan value from here, it's listed there, but the point of that is to show you how we divide fractions. Okay, A on B on C on D goes to AD on BC. Important to remember. All right, next one, we've got the angle 2 pi on 3, so let's find that on our unit circle, 2 pi on 3. Here it is, let's punch it out. We've got the sine value is root 3 on 2, cos value minus half, tan value minus root 3. Then we go to 315 degrees. All right, so find that on the unit circle. 315 degrees, the sine value minus root 2 on 2, the cos value positive root 2 on 2, and the tan value minus 1. Okay, so need to be comfortable, all right, looking at this and getting that information onto a table. And that's what we're going to do here when we're asked to evaluate these. Okay, we're asked to evaluate these. You could just put your calculator in degrees and type that in, all right, and it would evaluate it for you. But let's use the unit circle. It says sine 60 multiplied by cos 30. So we go to our unit circle. If you haven't got it out, have a look, follow along. Angle is 60 degrees. Sine 60, that's the y value. The y value at 60 degrees is root 3 on 2. Okay, so sine of 60 is the same as root 3 on 2. We're going to multiply that by cos of 30. So now we go to 30 degrees. 30 degrees, cos is the x value, it's root 3 on 2. All right, root 3 times root 3 is 3. 2 times 2, 4. All right, that's what it evaluates to. So you could put this in your calculator and you'll get that answer. But what we're looking for here and in the test situation is this substitution. Your awareness of that's what it is from the unit circle. All right, on to the next one. B, we've got sine of pi on 4 plus cos of pi on 4. So we look at the unit circle. Sine of pi on 4, okay, the y value, 1 on root 2. Cos of pi on 4, the x value, 1 on root 2. Alright, I've got one lot of root 2 plus another lot of root 2. I've got two lots of 1 on root 2. Okay? Two lots of 1 on root 2. Okay? You can think about it like that. I've got one lot of it plus another lot of it. I've got two lots of it, which is 2 on top of root 2. Okay, I've got that. When we multiply this out, top times the top, 2 times 1. What's the denominator here? It's on top of 1. 1 times root 2, so that's what it will evaluate to. Okay, on to C. C is a good opportunity for us to emphasize some bed mass. We have 3 times sine squared of pi on 3. Okay, so let's write bed mass up. And BEDMAS says we have to perform anything in brackets first, okay? So there's no operation to perform there, so we move on from brackets. Next is exponents, all right? So what we've got here, I'm going to just write it out like this to remind you of what's going on. Sine of pi on 3 squared. That's what it means, okay? When we put the squared there, it means the sine is squared. The 3 is not squared. If the 3 was squared, the whole thing would be in brackets. Only the sine is squared, and then we have take cos pi. All right, so before we evaluate it, all right, using BEDMAS, we need to look at the unit circle and go, okay, first my angle is pi on 3, all right, find pi on 3. The sine value, what's the sine value at that point? So here, the sine value is root 3 on 2, all right? Sine of pi on 3 evaluates to root 3 on 2. Cos of pi, so you go to pi on the unit circle. You find it. Cos is the x value. Okay, now let's do the BEDMAS, okay? First brackets, okay, no significant operation to perform there. Exponents, that means we need to square it before we multiply it, okay? That's the key thing here. So when we square it, we're squaring both the top and the bottom, okay? Root 3 squared is 3, and 2 squared is 4. We have this 3 out the front still, okay? So from this step to this step, all I've done is squared the bracket, right? And we have minus 1, that makes it plus 1. Okay, 3 times 3 on 4. Again, I've said 3 by itself, that's 3 on top of 1, right? Top times the top, bottom times the bottom. So we have 9 on 4 plus 1. Okay. And if we want to use fraction operations to add them together, 1 by itself is the same as 4 divided by 4, right? 4 divided by 4 is 1. So we'll simplify it to 13 on 4. Okay, so if you put this in your calculator, this is what it's going to churn out, but we're interested in the process of getting there, in the operations that you're performing. Okay, so that's question 1 and 2, so most of that's the same. let's look quickly at 3. And 3, all we're doing in 3 is, again, looking at our unit circle, but this time finding an angle. So look at the first one. It says, find an angle between 0 and 2 pi. That means we have to use radians, such that the y value is half. All right? So you know how to do this now using technology. That's what we were doing in D2. But let's do it using the unit circle. The y value is half. Here's half. That means I'm talking about this location and this location on the unit circle. In both of those positions, the y value is half. All right, we don't know what the x value is, not interested. But we want to know what's the angle that describes those positions. So for A, we've got sine theta is half. You look at the unit circle and you're going, where is the y value half? All right, there's 2 locations. Look at the unit circle. Y value is half. The angle is pi on 6. That's theta 1. And theta 2, 5 pi on 6. At both of those locations, the angle is the y value is equal to half. All right. So this time, rather than using the calculator, we're just looking at the unit circle. And then the next one, what about cos theta being root 3 on 2? Okay, cos theta being root 3 on 2, that's about 0.86. And so localize it. You can, if you want, you can run your whole finger around the unit circle and go, where is the x value? Root 3 on 2. You can run your, but think about this intuitively, right? Okay, it's root 3 on 2, the x value is positive, so it's like here and here, okay? They're the positions, and so you know where to look on the unit circle. You know it has to be somewhere here, somewhere here. What's the corresponding angles? Pi on 6 and 11 pi on 6. All right. Cool. So that's enough to get through 5E. I'm glad we got both of them today because it's going to just free up a bit more time towards the end of the term. Good. So let's crank on with that. All right. Use the unit circle. Become comfortable with it. Keep referring to it. And let me know if you've got any questions you'd like to ask about. Good stuff.